Hi, kids. So we're going to go through this one a little bit here. Slideshow from current slide. So we were starting matter, and this is what I should be doing, which is my homework. But this is just too boring, so I decided instead to do a tape about make a video of this. So let's start here, shall we? We were supposed to cover some of this, and the ones I asked you to cover, you should know what a Bunsen burner is. You hopefully know what goggles are. The Erlenmeyer flask is near and dear to me. Oops, not drawing well. There we go. As is the beaker. So long as I'm here, let me do that. So you should recognize the difference between an Erlenmeyer flask, which has a greater stability on the bench, and a beaker, which has a nice little spout and is good for heating things, because this will have something of the steam will kind of catch up in here, whereas here the steam can escape. So those you should know. Graduated cylinder, another very important piece that we will use frequently, and that's good for measuring out liquids. And the 24 well plate was the last one I was happy for you to know. And that sort of has replaced test tubes. They're basically very, very, very small test tubes. So if you just kind of cut off the very bottom of a test tube like that, that's what these well plates are. And they allow you to mix things and see reactions without having to use a lot of stuff. And we talked about how the scupula and the spatula are interchangeable for adding solids. All right, so matter. We talked that chemistry is the study of matter. Matter is anything that takes up space and has mass. And my real funny joke was that the cathedral has mass and takes up space, therefore it matters. And there you go. So, and then we talked about my daughter, the scientific method, and specifically how my daughter was using it for her emoji game. So here is an example of her emoji game. It takes 30,000 coins to buy, and what she wanted was this emoji here. She wanted her Moana. And as you can see, the Hui, I can't remember his name, something like that. The pig came up, and then she comes up, and then Maui comes up, and then another one comes up. And so she was trying to figure out, is the timing of this related to which one you get? So initially she thought the timing was related once the one she wants come up to hit this. So that was her purpose or question. Is the timing of when those things come out of that box related to when you get them? So that was the first step of the scientific method. Her second step then was research. What information is already known or has been figured out? So the first thing she did after she had this idea in her head was to Google to see if anyone else has figured this out already, because there's no reason for her to reinvent the wheel, basically. If this experiment has already been done and proven one way or the other, then there's no reason for her to proceed. So nobody had anything written about how to get the emoji you wanted. So she did her research. She had her question. So her hypothesis was an attestable claim. She thought if when Moana's head shows up, of all the possibilities of an emoji that you can get, she was going to press the buy button, and if that worked, then she would get Moana. If it didn't work, then she would get something else. So that was her hypothesis, her testable claim. Then she did her experiment. So she had to get enough coins, and this would provide evidence to test her hypothesis. So in this case, it was pretty straightforward. She was going to observe whether when Moana's head popped out of that little box, was it going to be the one that she was awarded in the game. So after doing that, actually, this also involves variables, factors that change in an experiment. So as you can kind of see, there's three heads that are visible at any time. So she could variable wise do it as soon as it shows up, or when the one after it shows up, or, she had to make sure the timing of when she hit the button was the same for each one. That's basically the only variable she was dealing with. And we'll talk more in detail about variables. And then the analysis and conclusion. So after she did all this, she found she did not get Moana. So the conclusion was it was not true, her hypothesis. And then her reanalysis, though, was, well, she got one 8 before her Moana. So then the question was, well, if she waits for 8 emoji after her, or 7, whatever it was, would she get the Moana one? So if she waited until 8 emoji showed up after the Moana, would that work? So that is the scientific method. You should remember that you have a question, you research that question, You form a hypothesis as a testable claim. Something will happen if this happens. You do an experiment based on that claim. So hopefully that claim is all that will be true if it works. And then when you get your data, your observations, and you've held constant the variables and that you needed, you can analyze your results and come to a conclusion and maybe reestablish a different hypothesis. So observation wise, there are two types of observations. There are qualitative and quantitative. And I said I'd switch these around and I still haven't. So qualitative are the type that are non-numeric. So in the case of this glass here, you can say it's green. That's not a numeric value. You can say it has a strong aroma. You can say it's smoking. You can say it has a medicinal taste or a spicy taste, whatever it is. These are all things that you can't really lay a number on. So we call those qualitative observations. Quantitative observations are based on measurable numbers. So the height of this glass would be something that's measurable, right? The height of this thing. The amount of liquid inside would be measurable. You could take the volume of it as 300 mils. You could take the temperature. That's a measurable with a number. Much less argument going on as to whether or not it's 30 degrees. You could argue whether it's green or sort of a chartreuse, I think is what someone said in class, right? That could be a qualitative observation, but quantitatives are less arguable, more measurable. So how high it is, the temperature, the volume, those type of things. Those are quantitative observations. And then we had variables. So variables can be either independent or dependent for an experiment. So when we talk about independent variables, those are the things that you're trying to select to test your hypothesis. So the independent variable in my daughter's emoji game was when she hit the buy button would determine when she got an emoji. That was the independent variable, is that the timing of when she hits the buy button will determine which emoji she gets. So the dependent variables are the results or outcomes. So in that case, the variable is which emojis does she get after she hits the buy button. So that is the dependent variable. So the independent variable is the timing of buying it, and the dependent variable is what she gets as a result of buying it in that time. We can also say that we'll get into some other things. And then there's control variables, which are factors that do not change during the experiment that you hope will help isolate your cause and effect, so that that independent variable is what caused your dependent variable and it wasn't something else. And these are more readily understood with examples. So we started here with the coffee. Does coffee help test scores? So if that is your question, does coffee help test scores? Your independent variable, the one that you're going to change from group to group to see if it has a result, is the coffee drinking. Are coffee drinking students versus non-coffee drinking students going to perform better? So that is the variable you're trying to isolate, and that's the variable you're trying to have a result from. Often there's just one of these. So you usually just have the one independent variable in an experiment. The dependent variable, the responding variable in this case, would be, does coffee help test scores? You're looking for the test scores. Now, you could have multiple responding variables, but in this case, there's just the one. Do students who drink coffee score better on tests? Do students who don't drink coffee do better on tests? So the manipulated independent variable is what it is you're testing. The dependent, the one responding, is what it is you're seeing the result of. And then the constant, the things you don't want to change in this case. We had some great ideas in class, but there are things like the test. You can't give one group a test in history and another group a test in math. That wouldn't be very equitable, and then you're not sure then if the coffee drinking is really what's making the difference. You want to have the same age as students. You don't want to have some that might be better at the test than others. You want to have a same gender breakdown, because again, if you're just hoping that coffee is the reason that the students behave differently, you don't want it also for someone to point out, well, half of your coffee drinking students were male, but over 80% of your non-coffee drinking students were female. So that's a different breakdown in gender, and maybe that was what was causing the results you found and not the coffee drinking. So you want to control certain things. You want to keep constant certain things. the same study habits, or at least same performance on tests. You want to make sure that you didn't just break up the group into people who are pretty good at math and people who struggle with math. And it just happened to be that the coffee drinking students were the ones who were struggling. You want to make sure that they have, you want to control a constant variable in the sense that they all perform the same and that it's an increase in their performance that they're doing. And some of you had a great idea that you should give them a similar test in advance and see if they did better after drinking coffee versus not drinking coffee. And that's a great way to really determine whether it's the same test and the same study habits and whatnot. So the control group is the group that are not subjected to the independent variable. So the independent variable here is coffee drinking. So the control group would be the ones who don't drink coffee. Those are the ones that you're making sure the coffee does something. So control and constant do get jumped around a lot, but the constant are things you want to keep the same for both groups. The control group is the one that is not being subject to the independent variable or the thing you're trying to test, basically. So the ones who are not in that. So we had another example of if you were trying to figure out where in the house a plant would grow best. So your independent variable would be where in the house the plant is, right? So you can have it where it gets a lot of light, you can get it where it has a little bit of light, you can get it where maybe it's warmer in the house, a bunch of things like that. So the position would be the independent variable. The dependent variable, the responding variable, would be how much the plant grows. So growth could be measured in height. You can also measure it in mass. So those are all dependent variables. And then things you want to keep constant, obviously, you would want the plant to be the same. You would want the watering to be the same. You wouldn't want to forget to water one plant over and over again because now that could be the reason one didn't grow. And other things that you would want to keep constant. So the control group for that one would sort of be, it's a little harder on that because you're just testing areas of your house. So I guess you'd have to break it down even further to, does a plant grow better by the window or away from the window? So the one away from the window would be the control and the one in the window would be the independent, um, the one that's being subjected to the independent variable. I don't know if that made things clear, but that's what we did. So then we talked about changes, and I showed you the Shrek video, which you can watch yourself if you wanted to. And we're talking about middle school things, physical and chemical changes. And when properties are altered, we say a change has taken place. So here is a pencil and you sharpened it. That is a change. And is it physical or chemical? You should know how to identify these. I've let you know this is a frustrating thing for me. I don't know that we really have all the tools to determine this, and oftentimes we just sort of memorize what the teacher keeps telling us. But here are some guidelines for physical change. So the identity of the substance remains unchanged if it's a physical change. And the best example, and another sort of hint or thing that helped me when I was doing this in 8th grade was it's often reversible. So for example, when you bend a metal rod, you can unbend it. So that's a reversible thing. That means it's a physical change. When you do something like freeze water, you can melt the ice back to water. That's a phase change. That's reversible. If you boil water, you can cool it down back to a liquid, and that's a phase change. That's reversible. So that's a physical change. Breaking, grinding, cutting. This drives me nuts, and I let you know that. But, if you cut grass, that's a physical change. It's not really reversible. And we just start arguing philosophy at this point. But anyway, chemical changes, one or more substances becomes a new substance. Examples of chemical changes are burn, rust, mold, rot, and grow. Grow is another one. So if grass grows, that's a chemical change. But if you cut that grass, it's a physical change. My sister tried to explain that one to me just recently, that, well, you have to water the grass to make it grow, and some chemical reactions are taking place for the grass to grow. But others would argue it's still grass. It was grass before, it was grass after. You can't say it has more of these, so therefore it's not grass, more cell walls or whatever. I don't quite anyway. Because if that's true, then why isn't cutting the grass anyway? I'm not going to confuse you. I'm just going to keep going. So also called a chemical reaction. So this is the point of all this. The point of all this is, and I will give you some gimmies of these on the test just to say we did it. But the point of this is when you're at the bench and we're doing chemical reactions, you need to determine whether a chemical reaction took place or not. And some hints that a chemical reaction or a chemical change took place are if bubbles form, then a gas is produced. That is an example that probably a chemical change occurred. And here, what you see here is a clear liquid going into a clear liquid, and this yellow solid is forming. So a precipitate or a solid forms. That's an example of a chemical change. When light or heat or some energy is released, that is an example of a chemical change. And this is very subtle, but what you see here is this changed color. And when change of color or smell occurs, then that's an example of a chemical change. And I believe that's where we stopped. Yes, so I'm going to stop this video here. Thank you very much for all you've done. Discard that, and we'll discuss more in a